We can extend and customize the functionality of our operating systems by installing applications. These applications are available directly from the application developer or for the app store that's associated with your operating system. But of course, not every application will run on every operating system. So in this video, we'll look at some of the important criteria to consider when installing an application. The first thing you should do is look to see what type of processor is supported in your operating system. Is it a 32-bit processor or is it a 64-bit processor? This single specification will have a big difference on the type of applications that we'll install onto this system. One of the biggest differences in specifications between a 32-bit and 64-bit operating system is how much total memory or random access memory can be accessed by that operating system. A 32-bit operating system can reference 2 to the 32nd power, or around 4 billion separate values of memory. In a 64-bit operating system, we can reference over 18 quintillion values. And if we compare that to a 32-bit that supports 4 gigabytes, we can have a 64-bit operating system supporting over 17 billion gigabytes of memory. Of course, it's not very practical to have a single system with over 18 billion gigabytes of memory, and in fact, many operating systems do have a logical limit on what the maximum amount of supported memory would be for that OS. This difference between 32-bit and 64-bit is also important when you're installing a hardware driver. That driver has to match the version of the operating system you're using. So if you're using a 32-bit version of the operating system, the hardware driver has to be a 32-bit version. If it's a 64-bit OS, it needs to be a 64-bit driver. With applications, this criteria is slightly different. If you're running a 32-bit operating system, you can't run applications that have been designed for a 64-bit operating system. But if you're running a 64-bit OS, you can run not only 64-bit applications, but also 32-bit applications. You can think of a 64-bit operating system as being backwards compatible and allowing you to also run 32-bit applications. If you're installing applications on a 64-bit OS, Windows will put those applications into a specific folder depending on if they are a 64-bit app or a 32-bit app. 32-bit applications are stored under Program Files x86, where 64-bit applications are simply stored under Program Files. So if you're trying to determine whether you can use a 64-bit or 32-bit application, you can look at the specifications for your operating system to determine whether it is a 64-bit operating system or a 32-bit operating system. The type of graphics processor you're using in your system can also be important when installing applications, especially if it's an application that heavily uses the graphics functionality in your operating system. Many computers include integrated graphics, where both the CPU and the graphical processing unit are on the same package. So when you install a CPU, you're also installing the GPU for your system. This uses the common system memory for the graphics, and if you have a small system, such as a laptop or mobile device, it very often is using one of these integrated graphics functions. This is very common to find in laptops and other mobile devices because you can effectively have both your CPU and graphics capability on the same chip. But of course, if you're using a more advanced application that needs more capabilities from the graphics of your system, then you'll probably want an external or dedicated graphics card. This is an example of one of those cards. We sometimes refer to these as discrete graphics cards. These contain their own processors, their own video memory, and contain all of the power you need to run these high-end graphics applications. If you're not sure what your application requires, make sure you check the documentation to determine if the integrated GPU will work or if you'll need a discrete graphics card. When you read through the specification of an application's minimum hardware requirements, one of those specs is for random access memory, or RAM, and that's the memory that you see on the module that we have in this image. We consider this to be a critical specification because your application and any part of data running for that application has to execute inside of this random access memory. And if you don't have enough memory, then you're not able to use that application. This is obviously a specification that goes above and beyond the requirements that your operating system is already using. So if your operating system requires 4 gigabytes of memory and your application also requires 4 gigabytes of memory, you'll need a total of 8 gigabytes of RAM to use that application. We often refer to the CPU, or central processing unit, as the overall computing capability for a particular computer. This is a very broad description, but it's basing this on the clock speed that's associated with a particular processor. For example, the clock speed on the processor on this image is a 3.5 gigahertz processor, and we can start comparing processors based on this relative speed. Of course, there are other criteria that help determine whether a processor will be faster or slower than another, but using a processor speed is a good starting point so that you can at least set a relative value between processors. This is another place we will need to reference the application specifications to see what the minimum CPU is for running this application. If most of your work is in a word processor, then you'll need a certain level of CPU. But if your work tends to be something like video editing, where there's a lot of processing that's required, you may need a more high-powered CPU to be able to use that application. One challenge that software developers often have is making sure that their applications are licensed appropriately. One way that these developers can confirm that their application is being used appropriately is by using an external hardware token like the one you see here. This is a simple USB-connected device that you would plug into your computer, and the application will only work if that hardware device is present. If the hardware device is not plugged in, the application will simply not launch. This can obviously be a challenge if you have a lot of different people in an organization that need to use a particular application, but you have a limited number of licenses available. You effectively have to physically hand this USB key to anyone who might need to use this application. It may be that you've never run into a licensing system like this before, and that's probably because you commonly see this associated with very high-end software that has a very high price tag. This ensures that anyone using this application has a valid license, and we know that because they have the external hardware token. Another important criteria during the installation process is how much space this application will take on our storage device. Normally, the application requirements will tell you that you need a certain amount of free disk space to be able to install this app. In many cases, the amount of space these applications use is very minimal and doesn't have a major effect on the system. But there are certain applications that use a very large amount of drive space, so it's important to know exactly how much needs to be free before you install the application. In the days before the internet, we would acquire software by visiting a retailer, purchasing that software, and then taking the software to our computers for installation. These days, we can simply download any software we might need, whether that's an operating system, an application, or anything else we can install on our system. Ideally, we'd be acquiring the software directly from the application developer or from an app store that we can trust. You would generally want to avoid going to an untrusted or unknown third party to install applications on your work or home computers. In some cases, though, you might be working with systems that don't have direct access to the internet, and this makes it a bit more difficult to install software because you can't simply download that software directly to the system. Instead, you would need some type of media to be able to load the software and then deliver that directly to that computer. You can do this through optical media such as a DVD-ROM, or put the software on a USB drive and connect directly to the system. Prior to the advent of downloadable applications and USB drives, we would commonly use optical media to install our applications. This might be a CD-ROM or a DVD-ROM, and we would need those types of readers in our system to be able to install the software. But even as the use of these optical media faded away, we still needed some way to be able to take with us the entire drive and be able to install everything that was on that optical disc. Fortunately, there's a standard format for taking everything that's on a drive and putting it into a single file called an ISO file. This ISO file is effectively a sector-by-sector copy of everything that's on that optical drive. The optical drives themselves have a very standard format for putting information onto those drives called an ISO 9660 file system. This file system was created to be a standard that we could use worldwide through the International Organization for Standardization, which is where we get the ISO abbreviation from. And that's why we call this an ISO file, because we've effectively taken an ISO 9660 file system and collapsed that all into a single file. Most of our modern file systems will recognize an ISO file, and if you double-click on the ISO file, it will show you on the screen a representation of what that original optical drive looked like in its file structure and content. So in this diagram, I have a single ISO file, which is called ESD-ISO. And when I mounted that file on my operating system, you can see that it looks like a full and complete file system. Instead, it's all running from a single file. I mentioned earlier that we have to be very careful about the source of these installation files and what you're installing on your system. That's because anytime you install an application on your system, that application is running with your rights and permissions. This means that any applications that you install will have exactly the same access that you do to this system. And if this application is poorly written or has malicious software inside of it, then it can create a lot of problems on your system. We also have to think about the impact that a particular application install might have to your overall system. For example, you might upgrade an application and then suddenly that application is no longer working properly. In those cases, you may have to downgrade the application or reinstall from a known good backup. There might also be times when installing a new application might slow down your entire system, or even worse, begin deleting files and other data from your computer. Of course, your system is also networked with a lot of other systems that are in your office, and if you install an application on your computer, that application can now communicate with anyone else who's on that network. If you think about rights and permissions that you might have to connect to file shares across the network, then that is exactly the same rights and permissions that the application has to connect to exactly the same data. We also have to think about the broader impact of installing a new application on a system and having problems that might occur. This could be a problem for people that need to complete some tasks quickly, and this application may be causing problems to the overall timeline. You could also run into situations where an updated application also includes an updated user interface or an updated workflow. This means that users may need to be retrained to continue using this application. And of course, installing an application could cause the entire system to stop working, which is why we always mention how important it is to have a backup before you start making changes to a system. And if you're running a company, you may be very sensitive to these applications working or not working. If you have problems with an application, you could have downtime, outages, and the overall business may suffer. It may be that this application is simply one of many tasks that have to complete for your overall job process to occur. So if you have a problem with the application, you could be bringing the entire business to a screeching halt. It's important if you're planning to install a new application or to upgrade existing applications that you've done as much testing as possible and you have a way to revert back to the original configuration if you run into problems.